Hello, my name is Tara Charlier. This is my final project for MIS 525 Business Analytics. My data set that I submitted for assignment number 3 was the Superstore orders. Had approximately 50,000 records with order numbers, product names, category, subcategory, with sales, profit, discount, and shipping cost per record. Each record is also assigned a region and market. Originally, I wanted to use this data to determine whether it'd be beneficial to cut certain products from either an entire market or just a specific region or regions within that market. I was going to start by determining the lowest profit by market and by product and see where it led me. So I was able to get a correlation matrix going to see if there was any relationship between sales, profit, and shipping cost that just didn't really look right. As you can see, when sales go up, so do shipping costs, which is exactly what you would think. Profit and shipping costs don't have the correlation that you would think. You would think that as shipping costs maybe, but I guess you wouldn't. You just are having shipping costs when you have profit generally, I guess, is why that would be such a low correlation number. And then I also was able to get profit by market using a sample of 5,000. I had to change the markets to numbers in order to get this. Maybe I didn't, but all the things above that snippet, I guess maybe I could have done it that way. I just worked around it somehow. But as you can see, market number 3 has the least amount of profit. I do wish I could have gotten something going with this, but I think only having 4 variables with quantities really hurt my progress, I felt. And I've always felt that finding or choosing the data set is always the hardest part for me. So unfortunately, I was unable to move forward. So for my final project, I have recreated some of the homework assignments. And I'll go into more detail about what we did and the outcome that we got. And how we sort of went about it too, and using RStudio and R in general. I apologize for this project not being completed to the specifications, but I hope my understanding gets me a few points anyway. So the West Roxbury assignment seemed more like a data exploration kind of assignment to me, and the R code that we got from Canvas, we loaded the data, made it a data frame. We found the dimensions of the data frame, numbers of rows and columns. You can say, do this head function down here. It'll show you the first 6 rows of data. Or you can say you want to just view the data frame. And in the picture there, you'll see it just lists the data frame or shows you all the columns and data for the data frame. The Boston housing assignment also seemed a little bit like data exploration. Once again, you load the data. Here we viewed the first 9 rows of data. And then it provided a Another useful approach for exploring is aggregation by one or more variables as well. So that's another approach. And then it provides a summary of the data. So it's just the summary of each column's data. So this was another just sort of seeing the different values or quantities we can get out of the data set, computing the mean, standard deviation, length, missing values of a particular column or variable, but you can do it for all of the variables. Here we have a correlation matrix with values rounded to 2 decimal places. So, and just like all things it seems like we deal with, it's between the values of 1 and -1. And what you're doing is showing the relationship, just like we did in the previous one, between the two variables. What kind of relationship? Is it a positive relationship? Is it a negative relationship? Is there not really much of a relationship? So, and here is a scatter plot of the Boston housing data set. And what it's showing is the LSTAT, or the lower status of population, and the median value of owner-occupied homes in the thousands. So as you can see, these two are negative. They have a negative relationship. As the lower status of population percentage, rises, the median value of owner-occupied homes lowers. Or I would say it'd be more accurate to say, just as the median home values go higher, the lower status population gets lower. I don't know. I guess it would depend. We're saying X value is the status of population is the thing. So utilities. Data set, cluster analysis, unsupervised learning. Here the goal is to find clusters of similar utilities. So it gave you a bunch of information about certain aspects of utilities, and then what you do is you remove the utility label from the data set, and then you see if there are other ways to group these utilities aside from, or if any patterns or groups emerge that don't really, that it's not by utility. So here's some snippets of a dendrogram. And to produce these, you would load the utility data. Prepare the data, like I said. You need to normalize the data. So using like z-scores, we all did that. So you must normalize or standardize the data because distance measures are highly influenced by scale of measurements. So you want to standardize all this so that it gives you a true account, I guess. You compute the Euclidean distance, which is basically the shortest distance between 2 points. And you do a distance matrix, sometimes referred to as a similarity or dissimilarity matrix. The distance matrix helps with classification of observations into groups by computing the distance, similarity or dissimilarity between each pair of observations. And then we see the single linkage dendrogram. And this one at each step. So you start with each at each step, the two closest records merge into one cluster. So that's what happens at the first step, the two closest merge. And then at the next step, the next two closest merge, and so on and so forth until you get your clusters. So here, this is a visualization basically of a cluster, different visualizations. So it's a heat map. So you can see, for an example, so the darker color means a higher value. So you can see like the top cluster has a higher load factor than the bottom two. And the top and bottom clusters have higher sales than the middle cluster. And then over here on like the sort of console side, I guess, we have k-means clustering set for 6 clusters. And then there was basically a cluster assigned to each of the locations or records. And then we found the centroids, which is a vector of variable means. And then as you can see, the load factor has a normalized average load factor of 1.1 in cluster 6. So Universal Bank. So Universal Bank had a lot of information about bank loans, credit cards, whether you had a personal loan, whether you had a certain bank account, stuff like that. And so right here, what we're doing is we're partitioning this data into 2 sets, a training set and a validation set. And this will give you data to create a good model and also data to test your model on. So then we run the logistic regression and use syntax GLM with family equals binomial to fit. And then you can view the first 5 actual and predicted records. So it's again the Universal Bank data set. What we're doing is looking at lift. And lift is a measure of the performance of a model, of a targeting model. And you can do a lift model of predictive error. And predictive error is using cumulative value of numeric target variable and cumulative number of cases in order of predicted value. So this Amtrak data we did a time series with. And so first, after we like load the data and all that stuff, we have to make the data into a time series object, I guess, instead of a data frame. So that's what we were going to do. This TS function turns data into a time series object. And then you can select a column to track with the time series. So the dollar sign denotes a column to take data from. And then here we also give a start, an end, and a frequency. TSLM fits linear model to data that has time series components. So, and then you want to add a predictor variable. So predictive variables are variables that are suspected to predict or correlate with an outcome variable. And the last, or the X label is time, and the Y label is ridership. So this is ridership on the Amtrak on specific days. So here, which I think is interesting, we have two different time series. So one of them is the full time frame of the data, so 1991 to 2004. The other one is more of like a snapshot. I guess I should have put those the other way around, of 1997 to 1999. So if you could see it up here in the top, you'll see that there was a, let me see. This first one here kind of looks like, you can see, okay, we're peaking in the summer, like June-ish, like halfway through the year. So it kind of looks very like you're having a seasonal thing happening. But see, once you fit the model or fit the regression, you can see on the one that's more spread out, that has the whole timeline of the data set, that's much more of a curve. And it's funny because you look at these two things, you could see two totally different things. Here you see more of a trend. It's more of like a long-term something that's impacting it. So maybe some sort of economic impact, like population growth or price inflation or something like that, was where this one just looks like, every summer kids come home from college and we get busier, so, or whatever it is. So depending on how you view the data and whether or not you add the trend to it can really change what you see. And placing them one above the other like that really sort of shows the difference. So, okay, thank you very much. Thank you.